Okay, people, planet Earth. Welcome back to chemistry. If you like my videos, please subscribe. It will be a great help and really appreciated. I'm now going to continue with the Nat 5 chemistry. And Nat 5 chemistry and cover the rates of reactions. Rates of reactions. The rates of reactions, they measure how fast reactants are used. Okay? Or you can say they measure how fast products are made. Okay? To measure the rate of any reaction accurately, one follows one of three changes. Okay? One, you can measure the change of mass of reactant or product. Okay? So if you have sodium plus H2O becomes sodium OH plus hydrogen gas. Okay? I didn't actually balance this last time, so to balance it, 2 hydrogens there, 2 there. There's actually 3 hydrogens there, 2 there. Okay? 3, 2. I'll explain balancing a little bit later. But to quickly, 3, 2, 2. Okay? So if you turn this into 4, put the 2 there. So there's 2 hydrogens, 4. And put the 2 there, there's 4 hydrogens. There's 2 oxygens there, and there's 2 oxygens there, and there's 2 sodium there, and you have 2 there. Okay? So you can write that like that. So 2 sodium atoms, 2 water molecules combine to form 2 sodium hydroxides, which is solid, and a hydrogen gas molecule, which is a gas. Okay? And this is solid liquid. Okay? So you measure the change in mass of the reactants as they drop. You measure that change. Or as they increase. Okay? As they increase in mass, you're getting more products. As they drop in mass, you're getting less reactant. The second thing you can follow is changing the volume. Of reactants or products. Okay? So with water, you get less water gradually as more sodium hydroxide is formed. Also as hydrogen gases form, so the volume of this would actually get lower. If you put lots of sodium into a litre of water, this volume would drop as this is released and as that's formed as a white solid. And 3, you get change in the concentration of reactants, or products. Okay, so those are 3 things you can measure: the change in the mass or the volume of the concentration. Another example is plus hydrochloric acid becomes carbon dioxide. Okay? I think this is calcium carbonate, I think. CaCO3. I think is that 1 minus? Which means you have to have 2 of those. Calcium carbonate. So you get increase in products and decrease in reactants as they react. So what am I doing here? Okay, so the loss of mass. So when you have the loss of when you have the loss of mass, what am I doing? The loss of mass. Sorry, the loss of mass of the chalk. Okay. Plus okay, HCl. Okay. So the way this reacts is you have a beaker. With dilute hydrochloric acid, and these are chalk lumps, okay? And you have a bit of cotton wool plug that stops spray getting out. Okay? And you have a $127 grams, okay? So there's a scale balance, okay? So as CO2 is made, it leaves the hydrochloric acid solution. Okay? So the total mass goes goes down, okay? The loss of mass, so the loss of mass in this is basically equal to the mass of CO2 made and escaped. Loss of mass is equal to the mass of CO2 made and escaped. Okay. The way you can measure this is you measure the initial mass and plus the mass every 30 seconds. Okay? So if you plot these as a table, which I'll do a rough sketch of, times seconds, mass of apparatus, grams, okay? So you have 0 times, that's 198.1 grams. At 30 seconds, that's 196.7 grams. At 60 seconds, that's 195.8 grams. At 90 seconds, that's 195.4 grams. At 120 seconds, that's 195.0 grams. At 150 seconds, that's 194.7 grams. At 180 seconds, that's 194.4 grams. At 210 seconds, that's 194.1 grams. Okay. At 240 seconds, that's 193.9 grams. At 270 seconds, that's 193.8 grams. And at 300 seconds, which is 5 minutes, that's 193.8 grams. So as you see, every 30 seconds, the amount of the loss of mass is actually getting smaller and smaller. First it goes down from 198 to 196, about 1.5 grams, and then about a gram, and then it becomes 0.4 of a gram, and then another 0.4, and then 0.3, and then 0.3, and then 0.3, and then it's down to 0.2, and then 0.1, and then 0. So the difference between these gets smaller every 30 seconds. Okay? So as this is being used up, the rate's getting slower and slower and slower. So what you then do, once you've got a data table plotted, once you've got a data table, you can plot. So you do a rough sketch of that. This is just a sketch. Ideally I should do it with a ruler or graph paper and very carefully plot it, but I'll show you how to use a ruler in a minute. So if you plot that on a time, mass of the apparatus, okay, grams. So 198. This shape of the curve is the loss in mass starts off big, but gradually gets smaller and smaller and smaller as time progresses, until it basically becomes zero change. So that here is zero change. And if you plot these 196 okay, it's